Good morning, good evening, or good afternoon. This is Miss Abney. I'm here to go over example one example one, try it from topic one, lesson 6. So here we have two different questions and we are solving system of equations. So I have this first one here, and I'm going to first follow the way the example did it, and then I'm going to show you a second method on how to solve these. So I'm going to have, what they did there is they separated one variable. They isolated a variable, and then they did substitution and found their answer through that. So I think looking at this one, tackling it in my mind, I am thinking I'm going to have to work with a fraction either way. So I'm going to choose y. And I'm going to choose y because 1, x is negative here, and 2, I don't have to do any division in the first equation. So I have 2x plus y equals negative 1, and then we're going to subtract the 2x from each side. And we get y equals negative 1 minus 2x. And then my second equation is going to be a doozy because it is going to be a fraction. So that's going to be fantastically fun. So we get 5y minus 6x equals 7. So I'm going to add the 6x to each side. Thinking if I actually want to do that, I'm going to back up a little bit actually. Nope, not that far. Not that far. Oh, did I lose my first one? All right, so I'm going to rewrite the first one. So this is y equals negative 1 minus 2x. And what I'm going to do with this y is I'm just going to take this and I am going to just substitute it straight in. So I'm going to take 5. Y in this case is now negative 1 minus 2x minus 6x equals 7. So the example had you solve the variable for both of them and then set those equal to each other. What I did here is I solved for y in one equation, and then I substituted that into the second equation. So I get negative 5 minus 10x minus 6x equals 7. Now I'm just going to solve for x by moving my constants over to the other side of the equal sign. So that's going to be negative 10x minus 6x equals 12. Then I get negative 16x equals 12. Divide by negative 16. And I get a lovely fraction of negative 3/4. So that's my x component. My y solution, I'm going to plug that into the first equation. So 2 times negative 3/4 plus y, it's plus y equals negative 1. These simplify out to, this will be a 2, so that's negative 3 halves plus y equals negative 1. I'm going to add the 3 halves to both sides. I need a common denominator here, so this 1 will become a 2 halves. 2 plus 3 is 5, so y is equal to 5 halves. Oh, hold on. Y is equal, this is a negative, so that's going to be 1/2. Always watch for signs. I didn't even watch for the sign there. So my solution is going to be a fraction. If I do this, if I do negative 3/4, 3 divided by 4, yep, that works. And 1/2. Check my answer. Yep, and there we go. Make sure you follow those signs. I did not follow the sign there, and it went crazy. So let's look at the second problem. The second problem, I'm going to use a slightly different method, something you might have seen before in pre-algebra or algebra 1. But what I'm going to do here is I'm going to, well, they're already lined up. So what I'm going to do is I'm going to choose, this is the elimination method. What I'm going to do is I'm going to choose a value I want to eliminate. And the way I'm going to choose that is, how can I get one coefficient to look like another coefficient with simple multiplication? So in this case, I can multiply 2 to 2 to get this 4. Or I can multiply 2 to 3 to get this 6. So let's see what happens. So if I choose, I'm going to eliminate y. So I'm going to multiply a negative 2 going through. So I get negative 6x minus 2y, nope, 4y equals negative 10 plus 6x plus 4y equals 3. Take that away, I don't know why that showed up. What I'm going to do is I'm going to add going down. And oddly here, I get 0 plus 0 equals negative 7. And 0 cannot equal negative 7. And so this one, I'm going to assume, is going to be a no solution. And the system has no solution. I know I went through that really fast, so let me again go through that again. So let me clear this up. So what I did here for the elimination method is, my thought process is I have 3x plus 2y equals 5. And what I did is I thought, okay, I'm going to eliminate this y because it'd be easy for me to multiply 2 to 2 to get 4. And so what then I did is I multiplied 2 to the whole thing. And I get 6x plus 4y equals 10. But if I compare it with the second equation, again, I want to eliminate the y. So this is a positive. If this is a positive and that's a positive, and I add going down, then that would have to mean that I'll get 8y, and that did not eliminate my values. So the next thing I know I need to do to get this into a negative, so when I add going down, is I'm going to multiply the whole thing by a negative, because what you do to one term, you have to do to all the other terms. So I'm going to multiply this negative to each of my terms, and I'll get negative 6x minus 4y equals negative 10. Now this puts my equation in a place where if I add the 4y from the second equation, I do get that 0. I do eliminate y. Now, unfortunately with this one, we also eliminate the first one, the first term, the x, because that also comes out to be 0. And again, when you have a situation like this, 0 does not equal 7, and that means that you have no solution. Now, if you get in a situation where you have like some number a equals another number a, and these are the same number, like 1 equals 1 or 3 equals 3, this type of situation is all real numbers. And this right here is a no solution. All right, guys, so keep your comments and questions coming at me. And next video, I will be working on the try it for example 2. So I hope you guys have a fantastic day, and I hope this helped you out a little bit more. So let me know in the comments. Bye.